Okay. So, it's Michael.
I'm muted.
Okay. Okay, so hello once again. Sorry for the previous minute because, yeah, the audio should be working now. So, sorry, we're okay now. And once again, welcome to another NgBeer Brno. My name is Christina, I'm from FlowUp, and today I'm going to moderate this event, so I hope you enjoy it. As the weather is very nice outside, I presume that there is not going to be loads of us, but it doesn't matter because you will be able to find the recording of the stream on our YouTube. So, if you'd like to stay informed about our future events, you can also join our meetup group, which is called FlowUp Meetups, and it's on meetup.com, or you can follow us on social media. And today, we've got 3 amazing senior speakers here, so I'm very happy to introduce them to you now. First one is Michael Hladky, who is Google developer expert for Angular. The second one is MATÉJ CHALK, who is our senior nowadays full stack developer. He's from FlowUp. And the third one is VOJTECH MAŠek, who is our head of engineering. And now it's a pleasure for me to give a word to Michael Hladky, who is going to be the first presenter. So enjoy. Michael is yours.
Thanks a lot. Can you hear me okay? I hope so. Otherwise, let me know. Very good. I'll share my screen. This is what we do when we present. Screen. There is a slideshow when we present, so we open the slideshow. You should see the slideshow full screen. Is this true?
I cannot see anything.
You cannot see anything.
You have to share it.
I shared it already.
Using the StreamYard.
I used the StreamYard already, but okay. I click it again. Now?
Yes.
Okay, did the same as before. Now, you should see slideshow. True?
That's
good.
True.
I need to move it a little bit like this, that I can see stuff when I'm walking. Perfect. Let's get rid of that sharing icon. Welcome, everybody. It's surprising for me that we have such a huge crowd in those Corona times. Not just kidding, the crowd is tiny. But okay, still. Today's title is RX Angular Concurrent Mode, highly performant UIs. And maybe you already realized that Angular React in the latest version, in the beta version, also released a thing called concurrent mode. And this presentation is basically all about the low-level technical details of what does it mean to have concurrent mode running in an application in a framework like Angular or React or wherever, and also how we did it in Angular specifically, and also, of course, a lot of demos. I will start to discuss the bridge from server-side to client-side rendering. I hope everybody is also able to see the second camera here, because I just for today pulled on my special socks. I want to compare server-side rendering and client-side rendering. I want to do this by comparing the old way of doing like PHP-style server-side rendered HTML that is sent to you, and the client side, the single page application style that we know from nowadays, which is you basically fetch one time a little bit of HTML and then everything else is just JSON data that you exchange. And to really stress out that server-side rendering is not the fancy server-side rendering that we know from, for example, Angular Universal, but really the good old PHP server-side rendered websites. With that in mind, let's not compare stack and framework, because this is what everybody is doing. Like they always compare server and client side with the stack, with the framework. Today, I will compare it from the browser side. So I want to talk about how the browser is handling server and client-side rendering, and what does it mean to the user. My name is Michael Hladky. I gladly got introduced, very welcoming by Christina already, but again, a small introduction. What I do, I'm a trainer and consultant with the focus on Angular. I'm Google developer expert in Angular. I'm Microsoft most, whatever this means, MVP, I forgot it, but I anyway don't care that much about all this title thing. What I believe is what you do and what you present and what you share. And this is the most important thing, so we should start with that. First chapter in a huge block of theory is rendering in the browser and responsiveness. What does that mean? I start with server-side rendering. And server-side rendering, how I understand it, is respond on request. Without me requesting anything, nothing is happening. And it always takes something that is called a round trip. So you have to receive some HTML, then you render the list. This is a list of items here that I schematically draw. And then when you sort it, I'm pretty sure some of you, the older ones, remember the times when we had like sort buttons next to each item. And whenever you clicked the button, you send a request to the server. The server basically processed all of the stuff, re-rendered the page, and then sent you the next result back, and then the item moved for one tile. And this is what we did, and this takes some time, as you see, like you click, you wait for the server, and then you can display. So not really nice and nothing that people nowadays use, or at least enjoy to use. And enjoyment of use is like the thing that we really should focus on. So what is client-side rendering? Client-side rendering is instant response. The moment when you touch, the moment when you drag tiles in your application, at this very moment, you also see the response immediately. Let me demonstrate that again with a client-side rendered with a single-page application here. And I received a list from my server client-side rendered. And then I don't have this button anymore. If I click it, then I send the request to the server. I can really click, drag, and drop the items to a specific place in the list. And every single interaction is snappy, is instant, and every single interaction is a joy. It's a joy for our users. So this is kind of a pity, because as user loved that, user got used to it. And users nowadays, especially on mobile phones, want instant response. They want instant response always and on any device that they have. May it be on their laptop, desktop, mobile phone, or tablet. They really always require this instant, snappy feeling of your application. Otherwise, they will blame you, they will blame the internet, they will blame the quality of your product. And if you maybe have a web shop or something else, maybe they just drop out and never ever come back again and buy at your website. Okay, so this is like what people demand, what people really want to have out there. And to go there, I want to introduce you to a couple of different theoretical chapters. Theoretical chapters that help us to understand what rendering is, how rendering works, and then how all those problems in rendering, like blocked UIs, frame drops, and so on, appear, what they mean, and how we can fix them. So let's start with scheduling. Scheduling is a very technical term, so I decided to make it a little bit more approachable for us, and I will introduce to you scheduling for humans. Scheduling for humans 101. If you see on this graphic here, we have a calendar. This is my calendar. This is my timeline. This is the dimension I live in, right? I live in time. Everything I do has time, takes time. And this is how I arrange it. And when I have certain meetings, certain actions, certain happenings, I have an event in my calendar, these blue dots here. And sometimes if I'm happy or not, depending on what meeting it is, I have an event. You see this highlighted event here in the last row. This is the current event that I'm in at the moment right now. And in this event, I could have a phone call. And in this phone call, I schedule a meeting for next Saturday where we will meet to learn German, mathematics, something that you would do in your free time, most probably learning new stuff, right? And this is like how I schedule a meeting, how I deal with the time in my timeline. What I can do is not only schedule a meeting, but I could also say, I realized this is maybe not the best time for a meeting. Let's unschedule it. Let's cancel the meeting and let's basically cancel stuff that did not even happen yet. These are the two things that we can do when we talk about scheduling in our human existence. What can browsers do? Scheduling for browsers 101. So if you look at this graphic, this is the browser's calendar. The browser's calendar has also boxes. In this case, the boxes are gray and they are called tasks. We will see later on what a task mean, but think about it as a day in the calendar of a browser. And if the user clicks a button, you see this like yellow box that I highlight now, this event. If the user clicks a button, I can run code, and the code that I run is a trigger. The code that I run is a trigger for scheduling work. I trigger it, I schedule, and this little box in the middle is the work that I want to perform in some point in the future. So I take that bunch of work and I throw it in the future. And at some point in time, the animation frame, this is the calendar day of which I scheduled to have this appointment, this block of work here, this blue bordered block. And this animation frame basically is my event in the calendar that takes the scheduled work and executes it. And this is the place when really the browser works off all the tasks that we gave him. And this again takes some time. This is what scheduling means for the browser. Now, as we know what scheduling means, we can discuss all the different methods, how we can use scheduling. Maybe to make this board crowd a little bit more interactive, do you already used any of the listed schedulers here? Yes. I see not too many, like one by one, not too many at once, but yes, I hear that the second one, somebody used the second one, queue micro task. Set timeout. Okay, so you use the first one, set timeout. Most of you use the promise. It's pretty technically from scheduling part pretty equal to queue micro task. And then we have the post task message, which is when you, for example, communicate to another browser tab. You can use post task message. It also schedules an event. I explained it already, the animation frame. Then we have idle callback, request idle callback. And I see that I have a typo here. So while I'm talking, I will quickly correct my slides, and you will not even realize that I do that. I just need to figure some time in my head to see how I fix that. And when I'm done, I jump back to my presentation. Nobody realized that I just fixed the typo here and there. And we can go to the last one, the post task scheduler. And I'm pretty sure nearly nobody, or let's check, is somebody here in the audience that ever used post task scheduler? Hands up. Krista, maybe you, Marek, yeah, no, nobody, okay. So post task is a scheduler that exists only and really only in Canary Chrome at the moment. Canary Chrome is known for shipping the latest shit, and you can go there, you can find it, and you can basically, what's so funny?
There's also another typo in the post task.
Ah, in the post task, I can do that again. I can like just while I'm talking, closing the full screen mode and type it. Thanks for correcting me. This is why you have audience, like everything live coding. I'm glad to have audience, and now I know I can also rely on you when it comes to typos. This is a really good feeling, and I'm reassured now. Good. Let's come to the next slide where I really technically show you how all those scheduling methods are performed. And I created a small snippet of code that executes everything at once. The blue arrow is synchronous code, means it executes immediately. The yellowish, brownish color is a microtask, a promise that you scheduled somewhere, or queue microtask. Then we have set timeout, we have idle callback, we have also post-task scheduler, and we have the animation frame. And this is basically an overview of all the scheduling methods that you can, nearly all the scheduling methods that you can use. Good. Now that we know all the different scheduling methods and what scheduling really means for the browser, let me go to the next theoretical chapter. The next theoretical chapter is the main thread and its frames. And this is really cool. I just realized I cannot leave my laptop, otherwise I will not be recorded. Pretty boring. Oh, I can walk with the table like this. So when I walk with my table here, I will talk about the main thread and its frames. And as before, I start with humans. I will explain to you the main thread for humans 101. So what is the main thread for humans 101? Again, we can go back to this timeline. We have days and units, and we can go even smaller in size. We can, if I go to the next animation, also chunk down to minutes. And then we are at a chunk size, I call it, or a frame size of 10 minutes. This is most probably the smallest piece of unit in which you can handle your life or manage your life. At least I'm not really able to manage it, but 10 minutes is a very, very small time frame. And this is, let's call it the smallest piece how humans can consider their time in a calendar. This is the frame for humans, or the task for humans. And there is also a task for browsers. You see the calendar of the browser here going from left to right, and every calendar day in gray here, or every task in gray here, contains some work. And every task is basically one unit of work that you cannot split up, that you cannot stop. And while this unit of work is running, the browser has to do the work that needs to be done. Nothing else. You cannot like look outside of the window or check, like, I don't know if you have Facebook, but check your Facebook messages. I have no clue if Facebook has a messenger, but I assume so. All the modern Facebook things have messengers. Yeah. And this leads us to the question, what happens if you put so much work in a day that you cannot really process it? If that happens, you produce a frame drop. And this is the third theoretical chapter that I want to discuss before we go into practice. And before I really do all the low-level details, I will try to search for a very random website. Let's try Angular.io, and if Angular.io is not working, maybe let's try Angular. And if Angular is working, we see this page, and I can open up the DevTools. And what I will do now is I will try to catch one of those frame drops. Are you ready? I'm so excited, I cannot tell you. Maybe it will not work, but I do my best. So I open the menu. Where is the menu here? I hope it is this. No, it's not. It is here. Okay, so this was the menu. Good. Let me prepare for a navigation. I navigate from what is Angular to the overview of components. I click here on the performance tab record, and then my browser will basically record every single piece, every single method, every single recalculation of the layout that happens and visualize it to me. So I click that button now. Now the browser is recording and I start to navigate from one page, navigation to the other, back, and then I click stop. And what I do now is, in front of the whole audience, I will live analyze these flame charts here and see if I can catch a frame drop. And I'm so lucky. I mean, there is a lot to see here, but if you focus your eyes on that part here, and I will highlight it and zoom in a little bit so that you can really see what I'm talking about. See that? Like the upper part, this bar here, this bar where I drag my mouse over, is the overview of the time we measured. And in that overview, I don't want to go into too much detail now. You see different colors. You see blue, green, yellow, purple. And all those colors mean work, different work for the browser. And then you see another thing. On top of the crazy color area chart, you see red bars. You see that red bars? Very good. Just for the people that watched the recording, they did not answer verbally, they just nodded. This is how I like to have my interaction with the audience, just like as less as possible, right? So, thanks anyway, I enjoyed it a lot. This red bar here is called a frame drop. And if I go now back and not zoom in too much, I can show you what we see. And if I zoom in a little bit more, beautiful. So here we see a task. And this task has gray stuff and something new that we did not saw before. And this is this red, if I would know the English word, this red pattern with lines, you know, this like angled, crooked red lines, and the red triangle in the corner. This is a task that is marked as long task. There is even an API that is called the long task API. Pardon, I need some sip of my refreshment drink here. And this long task is not good. Why? Because as long as the browser tries to execute that stuff, nothing can happen. So for a period of 158.02 milliseconds, the browser was not able to do anything. So let's go back to the slides. A little bit more theory, you know, like I love theory, right, from school. Oh, theory. So our theory again starts with humans. What is a frame drop for humans? And I will pull in an example from my actual life. So what you see now is my real calendar. Like this is really how it looks. And I did not made it up. I like copy pasted real events of my calendar here in this slideshow. And there is one thing that pops up. I already have the full calendar, and in between somebody calls me and they want this and this, and they have another question, and then they have another question, and they called me up, and I'm caught up in this call, and I cannot do anything. I cannot even do something about the fact that right now I should be doing something else. Same goes when I schedule a meeting next week when I already am fully booked. Also happens a lot. And normally, as I do a lot of consultancy and a lot of engineering for companies, I often estimate projects. And when people ask me, like, what do you think, how much time do you need? How long would it take you to develop this and that feature? I say, half a day max, right? And then, you see, this is what I produce in real life. This is like, it's not even fitting in like the size of the screen here. So this is how I produce my personal frame drops. And I hope that you feel from your own experience, what does it mean to have a frame drop in your life? You're stuck, you're caught up, and you can do nothing else than doing the stuff that you do right now. If this is not well explained, I give you another very, very speaking explanation. I stole it from Jafar the Cake, from Jake Archibald, sorry. I stole it from Jake Archibald. And Jake Archibald says, when a browser has a frame drop, it is like a sneeze. At the moment when you sneeze, everything turns black. No matter what you do at the moment, driving, sitting, reading, talking, you stop, you sneeze, then reality appears again and you know, okay, I'm still driving, did not hit the tree there, or okay, I'm still in the conversation, people did not left. So this is another good example of a frame drop. As we have now like the abstract way of thinking of a frame drop, let's go into the browser. And I demonstrated that already to you when I did this very fancy flame chart analysis in front of the full audience here. And this is a screenshot that shows exactly the same, a long task. So what is a long task? The browser itself considers 50-ish, 50-ish is what I would do. The browser does exactly 50-ish milliseconds. The browser says, it's okay, it's not enough work. I can constantly, in a really good frame rate, render images to the screen. But everything that is longer than the 50 milliseconds, so 50 milliseconds plus n milliseconds, is stuff that is definitely too long. And whenever we see this stuff in the browser, it means we have a frame drop. And if we have a frame drop, it means that users have a very bad experience. Users have a very bad experience, and in some cases, users are that pissed that, I mentioned it before, they will leave your application and never come back again. Do you really want users to never come back to your application again? No, of course you don't. So how to fix that? First of all, let's look what time did we spend on which work. And if I quickly sketch it up, we have like a lot of scripting and a little bit of recalculation. And as recalculation is a separate topic, I would skip recalculation completely and only focus on the scripting work. And if there are no typos left on that slide that I need to fix, I would switch to the next one. Like, take your time to check the typos. All good? Perfect. The audience approved. I can switch to the next one. The next one says demo time. And I demoed it already. So I can just, to show you that there are multiple of those, show you another frame drop. This is even worse, 300 milliseconds. And I also want to show you the difference between two frame drops. Let me see if I can manage that. Yeah. So this frame drop here, and this is this very box. Let me mark it for you. Everything I mark here in blue. So this is a frame, a dropped frame, that has only scripting work because you only see the yellow stuff on top. And this is stuff that I want to tackle in this presentation. But if we go a little bit more right, we see another blocking task. And this task here has partially scripting and partially relayouting. Here, this purple box tell me that something caused a relayout in my page. Here I have the highlighting who was like the trigger, but let's keep relayouting for this talk. But this task here would not easy to be solvable because we would need to introduce other changes, not only in our JavaScript. Now I did another demo of showing the flame charts. Now let's take all the theory we learned. I'm pretty sure you remember everything I told you the last 30 minutes, right? Again, they did not, verbal feedback. I thought like they only nod again, but it's incredible. This like, it's really motivating. I cannot tell you how nervous I am for all this like interaction. The next part is a little bit more practical. We will introduce main thread scheduling. Main thread scheduling is a special scheduling technique. To be more specific, under the hood, it uses the post-task scheduler in our case. Main thread scheduling has the option to schedule stuff, to schedule stuff in a prioritized way, and also to cancel stuff. So when we look at some native Angular code, in this case here, but pretty any framework has the problem that if they render too many sibling items, they got frame drops. So this is a list. And if we look at the image on the left, this is a huge frame drop. This is a huge frame drop because every list item takes some time, and the list here is rendered all at once. In one piece, without stopping, without breaking, without giving the browser time to breathe, to do anything else but working off that ng4. So, what exactly happened? If you zoom in into a frame charts, you could often see screens like this. For example, this here is a real-life application of a lot of subscriptions to components in a list that are caused when you navigate to that one. But we have plenty of other examples where you really see sequential processing of a lot of different tasks in a row without making any break. Good. What we did is we pulled out a use case. We pulled out a use case of a nested list. A nested list, I wanted to say, but yeah, you know. So this nested list has also some interactions. First of all, you initially load it and render it the first time. And this is like the init part. Then you click on a button, and every button click, you update all the items. And then you have an interval where you basically try to update this table as fast as you can. And all the different interactions caused frame drops. I marked those frame drops, and I even made a close-up of the bad part of the interval, just that you see how bad it is. And we took that example and we worked it off, and we worked on that for quite a while to finally introduce scheduling techniques that are also used in the React Concurrent mode, that are also shipped in Canary Chrome. So the latest cutting edge, fancy shit, whatever scheduling techniques we used and we integrated into Angular, and we at the moment call it concurrent Angular rendering instead of native Angular rendering. And if you take a look at that, you see that there are a lot of small, tiny chunks of tasks and no huge one task. This is basically the trick. You need to chunk up your work in pieces that will not cause a frame drop. So how does Angular concurrent mode render the list? If you have a look at that slide, the only difference are 2 characters. Can you spot the difference? Can you spot the 2-character difference in this slideshow maybe? Rx instead of ng, exactly. Really smart audience today. I'm impressed how interactive and really motivated the crowd here is today. Exactly. So there is only a 2-character difference, a directive, a structural directive to be more specific, that is called Rx4 instead of ng4. And this is everything you need to introduce. With this change, let me pitch this amazing, beautiful flame chart to you. Look at the initialization, not a single frame drop. Look at the clicks, not a single frame drop. And now, I'm so proud of it. Look at the interval. The first thing that you will spot is there is nearly no yellow. Scripting work dropped dramatically. There is even holes in between the updates. So the browser has that little to do that in between is just like taking a break and relaxes a little bit. All of that on top performs that fast that you can execute nearly 2 times the number of changes than you would have before. And this is like a dramatic, incredible change. It's so dramatic, it's so cool that I created another slide for it. I will show it later on. But first, if you want to have all the technical details on how we did it, I strongly recommend that you go here, that you copy that URL. It is basically one of our coolest issues, GitHub RxAngular issues /304 unmodified. And this small joke for like HTTP status, nobody got it. Okay, cool, I go on. Too unnerdy crowd today, but that happens someday. So here you see, we analyzed everything. I scroll through it. We documented stuff. This like proves that I can type English text. Still with typos, but I mean, it's a proof. Images, error handling, comparison. You see the comparison of those two, and close up and other stuff. Really beautiful. I really liked that issue. We are done with that. We developed it. We shipped it already in production in different huge applications. And in a period of the next months, we will publish it. We will publish everything because the building blocks for RxAngular is already published under RxAngular /CDK, but also RX4 will come soon. As I'm so hyped about RX4, I show again this comparison. Beautiful flame charts. I cannot stress it out enough. And I want to explain how we did it and finally come to an end, because I know that you are all thirsty and want to have a small break. So how did we get rid of all those blocking frames? Maybe you take a look at this beautiful graphic that is handmade. Like I do those graphics in between 3 and 6 in the morning. When my brain stops working, I go and draw some graphics. This is how I can relax. And I enjoy it a lot. But next to me enjoying the graphics, it's really like meaning into that information, because the first one is Angular native, and you see the gray box, which is the browser task, and the blue chunks, which is work packages that the browser need to work off one by one after another, take so much time that you have this red bar on top. It takes so much time that the task, the gray box, takes longer than 50 milliseconds. And maybe I did not explain it in detail before. Like we as humans, we assume that the browser has a frame rate of 60 frames per second. Otherwise, it feels janky, it feels laggy, it is not really a smooth and nice experience. Nothing that you would want to consume every day. In the below chart, you see concurrent mode. So what's the big trick of concurrent mode? There are two things in there. There is, first of all, notion of the frame budget, and second of all, priority. And for today, I will really focus on the notion of the frame budget. So when Angular, with our new code in place, starts to execute change detection, starts to render something, it will have like a list, a queue, a huge queue. Like the queue is longer than my emails in my inbox, right? Like never processable. And you take every single package of work and work it off. And for every package you measure, how long did it take to process that work? How long did it take? 20 milliseconds. Okay, then you take the next working package. How long did it take? 15 milliseconds. Okay, then you take the next working package. And after some point, you exhausted the budget. And your budget, you can configure it in our application, in our library, but by default, it is 60 milliseconds. So you have 60 milliseconds time to perform your work. And then the browser stops executing the blue chunks, schedules the next tick, the browser finally can breathe again, can do something else, can react to your click, can scroll, can zoom, you can interact again with your browser. This is not what you could while the task was running. Now, when the browser can breathe again, you can do it. You will have a click, you will have zoom, scroll. And then after that is done, the browser kicks in, like the scheduler kicks in again, takes the next package from the big infinite working queue and works it off again until the next task is full. Then he gives the browser time to breathe again, and then it goes on. So this is how we managed to execute only that amount of work that will not cause a dropping frame in your timeline, in your browser. If you don't think this is cool, we really have to talk. There is enough time after the talk where we have to discuss. Otherwise, normally I assume applause after that slide, but okay, let's go to the next one. The next one is, thanks. Yes. The next one, amazing, I know, beautiful. Thanks. The next one is like coding, because I hope that you all want to see me coding here and not only talking. So I came up with this tiny example here. When I put in 10 and I click the button, I display 3 components here, 1, 2, 3, and then a list of components here. You see a list, like many. And these 3 are standalone, and this list here is ng4. And if I open my browser and I adjust the width a little bit, just that we have a smooth space, beautiful. Let me add some more, like this number here is basically how much work every component consumes or needs to do. And now every component needs to do 30 work. Yeah, that's the unit, 30 work. And let me measure that, okay? I click on measuring again, I toggle in, I toggle out, I toggle in. And this toggling basically is simulating of a navigation. What happens when you navigate? You hide stuff and you display other stuff. This is what I did. And now look at those flames. Oh, you see it? A frame drop. Oh no, there's a frame drop. There is a 358.10 milliseconds frame drop. Terrible. The user hates it. I mean, this is unthrottled, not on my mobile phone with very good internet. Don't ask how it looks on your mobile phone, but this is what we need to fix. And the problem is that the browser, if I scroll down here, yeah, you see, everything after another has to perform all the different things here. Poor browser, so much work, no time to breathe. Let's start to refactor the application a little bit, and I hope that I can do that. I proved already that I can type English with typos, and I can also fix the typos if you mention them, only if you mention them. But what I will prove now is that I can also code HTML and JavaScript, some other languages, you know. So here are my 3 components from the top, and here is my ng4 from the bottom, this list. And what I do as a first change, oh no, maybe you believe adding async pipe fixes the problem. Just to reassure you, this is not the case. So even if we added those 3 components here, the frame drops still appear because it did not really change that stuff is rendered in a row. So what I need to do is I need to introduce one of our cool directives, and one of those directives is called RxLet. And RxLet basically enables you to leverage observables right in your template without the need of an async pipe or something else. Like this is like an ergonomic DX improvement, but it also helps us to chunk up the items. And if I go to my example page here and I type in 30 again, because this is what we had before, and I start my recording again and I toggle ops on and off and on and off. I go here. Stop the recording. Whenever I stop the recording, I have to wait until the recording is processed. This is the time when I switch to my talking fluff mode setup. Okay, it is done. If we zoom in, we see if I hover, after this huge blocking task, we have like already 3 chunks, which is like all of those components, every component from the top in one chunk. If I would reduce the work to like 1 item from 30, all of those 3 would end up in one of those chunks here. But here we have like 1, 2, 3 chunks of packages that got worked off. And down here we see like the work that is done. Okay, next thing, when we already fixed the first one, let's also fix the second one. And here ng4, and I basically just replaced the 2 characters here with Rx, and then I will add a $sign at the end. Okay, now I can go here and do the measurement again. I will click on record. I will toggle them 1, 2, 3, 4, 5. I click them for some time. I have a look at the flame charts. It's processing, so I need to come up with some words, but now it's done. And if you look at that beautiful flames, do you see the frame drops? No, because there are no frame drops anymore. Isn't that beautiful? I mean, there is nothing red here. There is nothing red anywhere. Everything is 100% smooth, non-blocking, and the refactoring was really as easy as possible. Even my grandmother could introduce those 2 directives and use it. I mean, I'm not sure if she would understand flame charts, but with a little bit of teaching, I'm pretty sure she could also show me why it is better performing in the flame charts. So this is how you can render stuff with the notion of the frame budget. One last thing, and really, really fancy, at least in my opinion, fancy thing, is that I want to showcase to you that it really pays off to have notion of the frame budget. And I'm not sure if you are used to Angular source code. So Angular.io, a website that I hate most of all. I did some PRs on it. And it has an interesting setup, some really cool stuff, like they heavily use web components, and some really bad stuff where they have some adapted routing setup, which is I really, what's the opposite of enjoying? This is what I did with it. But okay. What I want to search in that flame chart here is a very specific spot. And if you zoom in, there it is. I was lucky to catch it already here. Let me explain it. So what we see is a task that takes 225 milliseconds, 0.97, okay? And then we have animation frame, animation frame, animation frame, animation frame, animation frame. Okay, so we have, for some reason, somebody scheduled a lot of animation frames in a row somewhere in the past. Let's figure out who it was. And I click it, and in my browser, I have special secret settings. So I see that arrow, and now I have problems to navigate. And if I click that box and I follow the arrow, and I go to the very, oh, look how far away it is. So some ways to improve some bugs that we can already fix in the in the Angular.io page. But here we see that some dude NC basically and a lot of other NCs here scheduled animation frames, and animation frames will not process immediately. Of course, they will help. I cannot zoom anymore. They will get scheduled in the future to this very point here, but then, no worries, I'm done in a second. But then, like if they execute every one by one in a row, of course, if you have too much in a row, again, you end up in a frame drop, right? You see, it's still a frame drop. So this web component rendering, web component rendering, web component rendering in a row needs to have notion of the frame budget. And this is what I will do next. I will write a more lightweight scheduling technique and see to PR it to Angular. Let's let's see if they accept it or not, but I will at least try it to fix that problem and to introduce the notion of frame budget into Rx, into Angular's schedule detect changes method. This schedule detect changes method is a special change detection method only for web components and demonstrates in a beautiful way why we put nearly 2 years of work in this concurrent mode stuff. I gave you theory, I showed you flame charts, I claimed to know what's displayed in that flame charts. I live demoed how it looks, the problem in Angular. I live demoed the problem and how to fix it in my own application. And I showed you what things we could improve in Angular I/O. That's basically everything I have to show for today. I'm happy that everybody is still awake and not fallen asleep already. This cool graphic here, very cool. It's like a snappy response or something like this. I can only stress it out that I like my graphics that I draw in the middle of the night. Packages, RxAngular/CDK contains all the low-level details, the scheduling, the notion of frame, the change detection, the this and that. Then we have also other packages. Before I show you the other packages, please go to GitHub, open the repository, click on star button, because all the contributors love if you cheer us up a little bit. And how can you cheer us up more than with GitHub stars? Maybe GitHub payments would be cool, right? So second part of the library, RxAngular/templates. This is the RxLet directive, the RX4 stuff that we use in the HTML, and that's basically it. Thanks for your time. If you have any questions, there is my email address, there is my Twitter handle. If you want, I guess my phone number is also somewhere online. Feel free to ping me anytime, especially if you want to book performance audits, engineering trainings, or workshops. This is how I do my living. Other than this, again, thanks for your time and have a nice rest of the evening. Should we go directly to the Q&A session?
I think yes, but we don't have any questions in the YouTube chat yet, which I didn't mention. So please, if you have any questions on speakers, just write them down to the YouTube chat and they can either answer them immediately or after their talk. It's up to them. And excited clapping. And thank you, Michael. And as we don't have any question in here, I will ask the room whether there is any question. And if it's not, we can move straight to, okay, we've got a question. I will show it and read it. What is minimum supported Angular version for RxAngular?
Good question. So far, we didn't change a lot on the fancy stuff, so I believe you can use it with any version. We don't use fancy stuff. We don't use any Ivy parallel things. We basically introduced same, like normal general techniques into Angular. You could have introduced it years before, so I guess there is no minimum version yet. In the next release, we will kick out ECMAScript 5 bundling, we will kick out a lot of other stuff, therefore we will kick out Internet Explorer. We will most probably opt into Ivy partial compiling, and this could end up in support only for Angular 12. With this release, of course, we wait until we see how the usage is, but other than this, I would say for now, and before the next breaking release, you can use it in any version.
What about the RxJS or TypeScript support?
What about the RxJS or TypeScript support? A question from our great audience. So TypeScript in general we use pretty old APIs, so you should not have any problem also in more modern versions of TypeScript. RxJS, we use a lot of RxJS operators internally, so whenever RxJS 7 will ship in Angular, we have to refactor our internal code base, but as I know the RxJS code base quite a little, so if you don't really use an operator that has a completely different name, you can really have, how to call it, you can use both versions at the same time, theoretically. It is implemented, it is working, and beside the big changes in operator names, there should be no big danger for you, I would say. In any case, everything is hidden. So when you install the latest version, you should be sure that everything is working. Another question.
What is your favorite strategy for RxJS?
Favorite strategies. So strategies, we did not talk about strategies. Strategies are basically the way how we can tell Angular how to render. And there is the native strategy. The native strategy is what Angular is doing natively. And then we have like other strategies like only detect changes or mark for check with some other logic. And then we have a set of five strategies, and all of those strategies are concurrent, so you can schedule them with notion of frame budget, and you can also prioritize them. So every strategy has a different priority. The priority is the same as in React. So the aims are the same, also the techniques are the same. Change detection, of course, Angular is completely different, but I mean, we don't have a virtual DOM. We if our change in another way than other frameworks do, but other than the change diffing, everything is pretty much identical. Good answer? Perfect.
Okay. No more questions in the chat. No more questions in the room. So that means that, thank you very much, Michael. I think that we have never, ever had this energetic presentation so far. So thank you so much. And I now would like to introduce you our second speaker. I'm adding you to stream, Maciej. And just a quick mic check, because I cannot see that Michael was muted, so I'm not sure which microphone we were actually using. Were you muted, Michael, or not? Okay. But
Did we have sound? We had sound.
yeah, that's what I'm trying to find out, whether we are on with the sound or not. But nobody's. Yeah. Okay. Amazing. So. So I would like to introduce you our second speaker, who is MATÉJ CHALK. This is probably the first time I say this surname right. And he is going to speak about how TDD helps you build modular Angular apps. So I'm going away from here, and Maciej, it's yours.
Or just
How about
keep
now?
it muted. I mean, they still have the video, right?
They can
No
lip read.
sound, no sound.
No sound?
But
Yeah, we can
un-
hear it.
Yeah?
It's on now.
Awesome. I needed to unmute. Okay.
Next time I will.
Okay, so yeah, I'm MATÍJ CHALK, full stack engineer at FlowUp, and I'm going to talk about test-driven development and how it helps us build better, more modular Angular applications. Along the way, I'm going to mention these related technologies like Jest and X and Storybook. And I'm going to make this. Okay, but first I want to paint this picture of the nightmare scenario that makes developers unhappy, which I'm going to call drowning in tech debt. This situation where the project's been around for a really long time, there's a lot of business value involved in it, and they need developers, but everyone hates working for it for a variety of reasons. And so what are the signs of a situation? One is that we use this word legacy for a lot of the code base. It was written a long time ago. Nobody knows what it does exactly, how it works. The person who wrote it is no longer there. No one wants to touch it, but we can't delete it because it makes stuff work somehow. Adding features now, this picture illustrates it quite nicely. Somehow it's not so easy at this point. And anyway, we don't have time because fixing bugs all the time. And also when we fix a bug, it just causes other bugs. And we need to fix those, and this never ends because everything relates to everything else. And everyone talks about how we need to refactor the whole thing, but to refactor one thing, we actually have to sort of refactor the whole thing, and it's too scary. Developers don't want to touch the code because they'll break stuff. The senior developers are irreplaceable. They have all the domain knowledge, all the weird quirks. They're also completely burned out at this point. Can't replace them easily because the onboarding process is really slow because it's so complicated. So maybe you know a situation like this. Unfortunately, it's not so uncommon.
Never heard about such situation.
Some of us are lucky. Okay. So it's actually not that uncommon, unfortunately. It seems like maybe every application at some point gets into this situation, right? And maybe it's inevitable, but also we can probably prevent it, at least for some time. And so I'm going to talk about some methods of how we do that. And the answer is simple. You've probably heard this term before. Basically, the design of the application should have been better. We should do this modular architecture. And modularity is this really fundamental thing. Basically, we as engineers, what we do is we solve problems. And the sort of tried and tested way to solve complex problems, because the problems are very often complex in the real world, we break them down into small problems. If the problems are small and simple, we can solve those, and then we integrate them together, and we get the complex solution. And so this is basically how we approach it when we're designing. This top-down approach is the analysis, where we break it down, and then we split it up into small parts that we can think about in isolation. And then the implementation, we go from the small stuff, and this bottom-up approach is how we implement the application. This is like the classic waterfall is like these are different phases. In Agile, it's sort of, you have shorter iterations, but the idea should still be the same, basically. So the problem with this idea is that it's not that revolutionary. Everyone sort of knows this is what we should be doing, but it's actually quite hard to do. And it helps if we have some guidelines on how we should approach it. So I'm going to talk about some different approaches, and mostly I'm going to be talking about testing and a specific type of testing mostly. This is the testing pyramid, where we have the different types of tests that we write, and at the bottom we've got unit tests, at the top we've got end-to-end tests, and there's sort of different worlds really. With end-to-end tests, you're just looking at the application from the outside, this top-down black box approach of critical user paths. They're very valuable for the business, but they're also hard to write, complex setup, they run slowly, and so on. And unit tests, they're the opposite. They're the bottom-up approach to testing. They're sort of these lightweight things that they're easy to write, they run very fast, you can do lots of them. And because this is the bottom-up approach, when we're talking about modular architecture, I'm going to be talking about the unit tests, since for end-to-end tests, you don't so much care about the architecture because it's a black box. And then there's this wider topic of test-driven development, a bit of a buzzword nowadays as well, and people can be quite religious about this, but the basic idea behind it is that when we design code and we think about tests, when we're designing the code, we create better code. We create it more maintainable. And also, since we design the codes and we think about tests, then this gives us also the ability to actually write the test before we actually implement it, because that's how we're designing it. And there's also this little cycle here about red-green refactor, which is sort of test-driven development loop. And I'll give you a quick example, but in general, it's reported that test-driven development, just like doing proper design and stuff, in the initial phases, it sort of slows you down, but later on, it pays off a lot in reduced effort. So if you think about long-term, it's a pretty good approach. So how does the test-driven workflow work at sort of like a small level? Basically, first we design. Here I'm just going to have a function, so I'm just going to write a function signature. Then not going to implement it yet, prepare the unit tests, then I implement the tests. So for example, say I need to take 2 dates and get the number of days between them. I need to display that. So I know I need a function that takes these 2 inputs. These will be strings, for example, return a number. That's all I have at this point. That's just design. That's just the function signature. And the body I'm leaving empty at this point. And then I prepare the test cases. So here I'm using Jest. It's very simple. I map out the various inputs, the various test cases. So for example, if it's the same day, then the results should be 0. If it's 3 days off, then the results should be 3, and so on. Also, if the dates overlap, then it should be a negative value. Think about all the different edge cases. And then with these tests ready, and the tests are failing at this point because I didn't implement anything, I start doing the implementation. And my goal here is to just turn those red failing tests into green passing tests. And if you do well, this can be actually quite a nice, satisfying workflow. A lot of the time. It doesn't always make sense in every case. Some sort of advocates of test-driven development say you should always write the tests first. If there are no tests, then it's worthless. You should do 100% code coverage. I don't think it makes a lot of sense. And there's this really good article that I'd recommend about selective unit testing, where you explain that actually, no, not everything. Sometimes the tests are really beneficial, and sometimes it doesn't really make sense. So when is testing beneficial? In generally, application logic, business logic, algorithmic stuff, parsing, transformations, filtering, this sort of stuff. Basically, sheer functional programming, and just taking inputs, transferring the outputs, not doing a lot of side effects and stuff. This stuff is really good to test, and it can be quite complicated, so the test can be very valuable. But on the other hand, sometimes it's more difficult. For example, if your code has a lot of dependencies, then generally in your unit test environment, you're just testing this one unit. So you mock out the external stuff, but then if you're mocking it, then it's not maybe so valuable, and it's also harder to maintain. So examples is stuff that does a lot of side effects, like API requests. You don't actually want to request stuff from your API in your test environment. In DOM interaction, in some cases, all these sort of integration layers, like these sort of wrappers that you might create, might have very little logic, but also pretty complex to test, actually. And so the number of dependencies, it generally is like a good metric of how hard the test is going to be. If there are a lot of dependencies, they may also change, and you'll have increased maintenance for your tests. So I have some examples. of here examples where testing is really good. So for example, some sort of string formatting, when we're displaying stuff to UI, and like when using Angular pipe, for example, that's the type of stuff that we do. Here all we have is a function. It's generating a combination string. We give it a list of text, and it's going to separate them with commas, but the last one is also going to be using like a joining word, which is sort of nice in English and other languages. And here the tests are really easy. There's no setup logic. We just plug in the input the same as we do when we actually execute it in production. We have a different test case for all the different, like if there are 0 items, then we think about that edge case and so forth. And we're not even programming. We're just mapping inputs to outputs. Just a list of examples. Regular expressions, that's also another one. We might use them for validation. Regular expressions, once you've written them, are pretty hard to read in general. So it's actually nice to just have a unit test suite that shows you that it works and what it does. So again, just regular expression, call test, and expect if it's true or not. And we just go ahead with all our use cases. Object transformations. Here we've got, again, it's a pure function, takes 2 parameters, give an array of entities of some sort, something that we fetch from the API, and also we give a string, what's the identifier property, and we create a lookup table so we can look it up fast, like for storing in our state management, for example. This is more efficient. And we're using this to-equal matcher, so we can actually just pass in the object as is, and it's very easy to you don't need to see the function implementation. You can just look at the unit test and you understand what it does. And we also have edge cases, like if it throws an error, also pretty easy to do. So here's an example of where the unit test doesn't make a lot of sense. So this isn't the test, this is the actual production code. And here we just have a simple wrapper service for the HTTP client. And what it does has some methods, and it uses the HTTP client to send requests, and it's just forwarding parameters and return values without really changing anything. So the implementation, pretty simple. But the unit test, because we don't want to actually hit the API, we need to do mocking, and it actually gets quite complicated. So we need to pass in using dependency injection, so it's easy to do mocking, but still we need to mock the HTTP client just so that we pass in what the value should be and check that the value we passed in is the one we get when we run it. We can check that the function was called with correct parameters. But still, there's a lot of setup here, and it's more obvious to see what it does by looking at the test in this case. So I would say here probably doesn't make a ton of sense, this sort of test. So to help us sort of decide when we're thinking about code if unit testing is going to be beneficial or if it probably will be a waste of effort, I created this decision tree where basically the first question we ask, is the code complex in some way? Is it not obvious from reading it what it does? Is it very risky that we want to verify that it actually works? It's non-trivial in some way. If not, then we don't really need to unit test it. And if it's got a lot of dependencies, it would be hard anyway. But if it is, we need to test it, and here's the key question: does it have a lot of dependencies? In order to test it, do I have to do a lot of complex setup, a lot of mocking? If no, then it's perfect. We should write unit tests. Unit tests, we'll have a good time writing unit tests, and they'll probably bring us a lot of value. But if we do have many dependencies, then we have a problem, because we need to test it, because it's important to verify that it works, but it's also going to be hard to write the test. And so what we can do here actually is, this is where the tester and development is guiding us into making our code better. We want to refactor this. We want to take the part that is sort of the algorithm, the logic, put that into one part, and take the coordinated stuff that is integrating all the external stuff, but with a really simple logic, and that'll be the other part. And then once we have two different parts, we can run through this again. For the algorithm, the code is complex, yes. Doesn't have dependencies, no. Unit testing will be good. for the coordinator. The code isn't complex, no, so we don't need to care about unit testing, don't need to care about would be difficult. Can I have also another example, but first, just some random tips for writing good tests in general. So I really like this idea that a test is basically a form of documentation, because what it does is actually describing the behavior of how it works. You saw some examples before, just examples that you'd maybe write in a README file if you are putting a library on GitHub or something. And unlike other documentation formats like comments and so on, it's actually provable that it does work, because you can run it and you see, yes, that is actually the behavior. With unit tests, each test should not depend on other tests. That's also another really important principle. This also means stuff like if shared setup logic should be avoided if you can. It should be an exception. If I just look at this one test, I understand what it's doing, why it works. I don't need to look up some other stuff. But also, even more importantly, one test failing or doing something should affect any other tests. There shouldn't be these sort of side effects that the tests affect each other, and if you ran them in a different order, it would work differently. This should be avoided. This should be truly independent. And also, this one may be a little controversial. With unit testing, the don't repeat yourself principle that a lot of programmers use. With unit testing, I don't think makes a lot of sense. I think what actually does make sense is the keep it simple principle. Because if we want the test to work as documentation, then just simple, stupid, this is the input, this is the output, works really well. But if we do a lot of complex programming, then now I can't read the tests anymore, and it's not really good documentation. And okay, it's maybe more clever, maybe you didn't repeat yourself so much, but also you're probably extracting stuff and putting into this shared setup logic, and the tests are no longer independent, and to understand what it does, I have to look somewhere else. Dry is good when for production code, but testing code is a different beast, I'd say. Okay. So I have a quick demo. Here I'm just going to show you one component. It's like this poll. What it does is shows you the options. If you haven't voted, then you just see what the options are. And when you vote, it shows you which one you voted for, and also it'll calculate the percentages. And I've got 3 different versions, and we're going to go from the worst one to the best one. So in the first version, when I've got this input, which is some poll, and I've got some poll model, which is how it maybe came from the API or how it's stored in our Redux store or something like that. And so a poll has an ID, a title. It tells us if the poll is expired, and also got a list of options. Each of those has an ID, a label, a vote count, so the percentages we have to calculate, and also tells us if the user has selected it. And so because for actually rendering this, I need to calculate some stuff, like it's really useful to have this flag, this user can vote flag. It actually changes how the UI is rendered. You can see I'm using it in 4 different places. Also, the poll percentages I need to calculate. So I have in my component not just the input, but also calculating the user can vote, is any of the options selected, or has it not expired? And the poll percentages also I need to calculate, add up all the votes and divide them, and also round them up so we don't have decimal numbers because it looks bad in the UI. And also the click event will dispatch a Redux action in this case. So if I actually want to test this, I need to write something like this. Because it's all in the component, it's all in one place. This is what sort of people do by default. They just put it in the one place because that's more straightforward when you're starting out. So I actually need to, if I want to see the percentages are calculated correctly, I actually need to render the HTML. I need to know how to do all this Angular testing stuff, compile the components. I need to know that if it has providers, which this one does, because I'm injecting a store, I need to mock it in my unit tests. I need to know about component fixtures and that I need to tell it to detect changes. In order to fetch stuff, I need to have some way of finding it. Here I'm just using CSS classes. That's pretty flaky because they could easily change. Probably have to have a lot of maintenance with this test. And in general, there's sort of a lot of setup work. And if you're writing tests that are this complex, it's hard to be in the mode of just thinking about this edge case, this edge case, this edge case, because you're doing so much setup work. At some point, you think that's enough. And so actually, we do have some unhandled edge cases here. Actually, if you look, these numbers here don't actually add up to 100% exactly, because we're doing some rounding. So maybe someone cares about that. And the test with this complicated, we actually didn't think about edge cases like this. So can we do better? Basically what we do, we want the logic, the transformations, that's the stuff we want to test, but we also want to test them without caring about the HTML stuff. And one way we can do that is we lift out the logic, and we have this converter function, which takes the API model, which is sort of convenient for transferring over the network. But for the view, we may actually want a different model. We actually want in our view model to have a user can vote flag, because that's useful in our HTML, in our template. And we actually already want to have the percentages calculated. So we have a function that takes one input, takes an object of one shape, transforms into an object of a more suitable shape. All the logic is in here. I'm actually handling more edge cases than I was previously, like making sure the votes add up to 100 and some other edge cases. And it's just a pure function. So the tests are actually really easy. Here's sort of a basic one. This is the input object. This is the output. That's it. The title will get there. The user can vote gets calculated. And then I can also go through test cases really easily. So here, actually, it's also good in tests if you can only specify what's relevant to the logic. So here I'm just using typecasting and this sort of partial object matcher. So I can only specify stuff that is relevant. So I'm making sure, is the user can vote flag true if none of the options are selected and it's not expired? Yes, it is. Very simple test. If they've selected one of the options, then the user can't vote. That's another test. If they didn't select anything, but the poll has expired, then also they can't vote. Another test. We've got the percentages calculation, the rounded is an edge case where you make sure it actually makes them add up to 100%. And also another edge case, if they're all 0, then to avoid dividing by 0, we make sure it doesn't throw an error, basically. So the code is simpler, and we can test it a lot more easily. Okay, so we talked about testing. I also want to talk about sort of modular architecture on maybe sort of larger scale. NX, if you haven't heard of it, is a set of tools basically from a company called Narwhal. It's sort of this smart extensible build framework in their own words. If you're already using the Angular CLI, then it's actually very little learning curve, because actually all the same commands work. ngserve, ngbuild, it's all the same. Just add some extra stuff because it's actually extending the Angular CLI. So it's actually a lot of those commands are forwarded, but it gives us a lot of this extra stuff. As far as the advantages, like one of the more obvious ones is that Angular sort of has a lot of older technologies that it comes pre-installed with. Some of them are deprecated, and with NX you get all the newest ones. So like Jest that I've been using, ESLint instead of deprecated TSLint, Cypress instead of Protractor, it's also deprecated, I think. And also it sort of scales up to, you can have it's a tooling for application monorepo, so you can have multiple applications in there, and they don't have to all be Angular. You can also have React in there or some backend frameworks. It's in general very extensible, and if you create a new NX workspace, there's just one command you type and it'll set it up for you. So that's basically what NX is. Why am I talking about it? Because again, it sort of helps with this scalable modular architecture idea. So when you have multiple applications and you want to reuse code between them, then you need an organized way of approaching this. And with NX, what you're told to do is create libraries. And you can import them in multiple applications or between each other. And NX is actually going to manage this dependency graph, which you can see here. So you have an end-to-end application, which is dependent on the client application, on some client feature main library, and also on some shared components library, which is then used by the admin application in the end. And so NX actually tracks all of this for you, and it can make sure, by just setting very simple intros, that you keep your dependency graph clean. So for example, you don't have circular dependencies in there, which cause all sorts of problems. And also you can be more advanced. You can sort of do this tagging system and make sure the scopes actually make sense from when they don't change unexpectedly when you're importing between your libraries. And also it's stable vented track only code that is affected, so your CI is also more optimized. The last technology I want to mention is called Storybook. It's an open source tool for building UI components. And the idea is that you build UI components in isolation, which is why I think it's interesting. The idea is you create stories, which are these use cases for your UI components. And there's a lot of stuff you can do with Storybook. They have all sorts of add-ons I'm not going to talk about. Easy to set up. I'm just going to show you a quick example. So here I have the same poll component, and this is Storybook. It's just running locally. So you have reload and everything. And here we have the different use cases for the components. And these are what are called the stories. So haven't voted yet, that's one story. User already voted, and user didn't vote, but it's expired. It's 3 different stories, very easy to visualize. And I can also make the stories more dynamic, like I can just have these, what are called knobs, and play around with inputs, see what it looks like. Also, I can just quickly check, does it still work okay on mobile or on tablet? And it's pretty easy to write. Actually, I have this add-on that shows me the source code here, or I can go to my editor. Basically, for the component, you export some metadata. Here, for example, we need, as in the test cases, to do some, inject some providers, mock them in some way. That's the part we want to refactor. But then you just export these different stories, which is a function that, again, returns some configuration for your test. And basically, that's the inputs that you pass in. So you pass in different inputs, and those are your stories. And this is all the source code for those 3 stories. So that's very nice, but as I mentioned, I have to make it work, I need to mock all these providers, because if you remember in my poll component, I'm still using the store because I've got this click event and it dispatches an NGRX action that does the API request. And it's more complicated than it needs to be. It's actually not what's called a...
Font size is bigger.
It's better.
A little bit more.
I can do also
Yeah.
this thing.
Beautiful.
Okay, thank you. So we've got this this external dependency that's actually making it harder to write these, what I see basically as test cases for the UI. Like Jest is, that's the test cases for the logic, and this is test cases for the UI. So we can actually make this simpler. I mean, here it's not so much a problem, but if you have a lot of providers, it does become a problem. So what I want to do here is make it into a sort of purely presentational component, a component that just cares about rendering stuff, and it takes some inputs, which is how you configure it. And if there are some events, that it just passes those as outputs, and I do the NGRX stuff at a high level in the component tree. And so this is the third version of the component. It looks exactly the same, only thing I don't need any of these providers here. Also, I can do other stuff. If I have an output, I can actually see this actions tab. Like if I click on stuff, then here it doesn't do anything because the user can't vote, but here I can see I actually do these click events. This is the event that's being triggered. So yeah, it's a sort of, again, to make integrating Storybook easier, it's also, again, forcing me to split up my components into the smart ones and the dumb ones, the presentational ones. And that also helps make my application more maintainable. And you get this really nice showcase of components. Some random tips that I didn't know what other slides to put them in, just sort of making code better quality. This one principle is that when you start working on tasks, the first thing you do shouldn't be to just start typing and start coding, because the solution you can't won't be the smartest, and if you've already written it, you don't feel like changing it. Actually, probably better than just starting coding is to maybe take pen and paper and just start designing your solution in some way. Analyze the problem, design the solution, then you start implementing and breaking it up into smaller problems and all the stuff we talked about. Another thing is naming. It sounds silly, but naming actually really matters because, well, actually, there's this sort of infamous quote about there are just two hard things in computer science, cache and validation, and the other one is naming things. With names, if you pick a bad name, names sort of tend to stick around. Often you can't change them. So it actually makes sense to just sort of don't just think about it for 1 second, maybe just consult with your teammate if this is a good name, because you're going to be using it a lot. And if you pick a good one, it's self-documenting. Communication is easier and everything. And also, once you pick a name, be consistent. Don't just use different words so that, I don't know, your project manager says it's a blog post and you're calling it an article, or some people call it a toolbar or a navigation bar or a menu. Just sort of maybe even create a glossary. Just make sure everyone's using the same words. What's displayed in UI should also be how you name it in your code, and so on. And also, this is like a good habit to get into, is in general, if stuff gets big, if just the file size gets big, your function is getting complicated, just split it up before it's too late, because at a certain point, it just gets too hard. So for example, you might think, okay, this file is 300 lines of code. That's still maybe okay. But then when it gets to 1,000 lines of code, then actually you think, if I had split it up and it was still 300, I could still do it, but now it just feels impossible. So it's just something to always think about. Maybe just agree a maximum value for lines of code of your files, your functions. Linting rules make this really easy to monitor. Okay, so a summary of what I've been trying to say. So we started this idea of, tech debt is a bad thing. We hate it. It makes our lives miserable. How can we manage it? Modularizing app architecture. Probably heard of it before. We all know it's a good idea, but it's what's called a truism. Like everyone should focus. Everyone says this. Obviously, we should do this, but it's actually hard to do. That's why we keep saying it. So we need some guidance to how we can actually approach this. And I think if you do unit testing and you think about it selectively, like I want to write tests, but I don't want the test to be too hard, so I want to design my code in a particular way, then actually that will lead you to modularizing your code and breaking it up and basically deconstructing into large modules into small isolated modules that you can just think about this one module. And if you need to refactor it, then the refactoring is manageable and so on. Also, you get separation of concerns, like examples before, we're separating business logic from UI rendering. It's also a really good side effect. Single responsibility, another important principle. Idea is, instead of doing 5 different things sort of okay, you do one thing, but you do it really well, and we know that you do it really well because we can test it. Then also on a higher level, we've got tools like NX, which sort of organize this more complex solution spanning maybe multiple applications. We're creating these libraries that sort of need to be isolated and documented and tested in one place. And also thinking about what's my dependency graph looking like can prevent a lot of problems. Like avoiding circular dependencies is really important. Vojto is actually probably going to mention it when he's talking about lazy loading. It causes all sorts of problems in general. Loose coupling. If you 2 things are tightly coupled, then you can't change one without affecting the other one. Refactoring and generally reasoning about your code is hard. So you want to make those interactions really minimal and clear. And then we've got the the business logic stuff and the high level graph, the dependencies between our modules, but also in the front end, we obviously care about UI. So I think Storybook here is really helpful, where we actually create these presentational components that just care about UI, and app logic is done somewhere else. Yeah, so that's it. Hopefully it made some sort of sense. So thank you, and yeah, if you have questions.
Okay.
I think Michael has a question.
I have a question. What was the biggest file you ever saw in lines of code?
It was tens of thousands.
Tens of thousands.
Tens of thousands.
Did you chunk it up?
There's no way. There's enough at tens of thousands. There's little you can do.
So you should just add more.
I think you need to take that file, tag it as legacy, and just creating a new thing that replaces it at that point. Probably
10,000 line file.
No, do it better this time. Learn from mistakes.
How do you? Can I ask another question straight away, or should you want to have the rest of the audience?
Yeah, you can go ahead.
I can go. Okay. So. Thanks, audience. Testing asynchronous code. How do you do that?
Yeah, so that's the more complicated stuff, but sometimes it's also really useful. With promises, with Jest, that's pretty easy. Async await is natively supported. With RxJS, it can be more difficult, but marble testing in general is a really good idea. It's like this declarative thing of just mapping out the timeline of when events happen. And yeah, I didn't talk about that, but marble testing for RxJS is a pretty good way.
I have keep on the same question, like still same questions, not the third one. To keep the same question, when will, for example, Jest or Jasmine or whatever testing framework is out there support all scheduling APIs, still asynchronous testing? I know that Jest, for example, is not supporting the post-task scheduler API, is not supporting other stuff, and whenever you have some piece of code that is using this or that library, you get an error, it fails. It's very clumsy and hard to test code, and my code is mostly heavily asynchronous.
Yeah.
So
the problem with Jest, for example, uses the JS DOM, so it's emulating only some stuff, like some common stuff, but not everything from the DOM API actually is emulated, or you'd have to mock it in some weird way. So.
Well, that's similar things like time. If you depend on time in tests,
yeah,
then you have to mock it, or otherwise you have hard time.
Visualize it, or really set it hot, statically hot coded.
Yeah, with RxJS, you can abstract time quite nicely, but yeah. Also, change detection is another one. That's in unit tests, you saw that fixture detect changes. That's not how it works in production, because Angular does this automatically, but doesn't always work. But in your tests, you just tell it detect changes, and it's nothing like how it runs. So.
But that makes sense, because it's not what you are testing. You are testing the utility, the business function, like business logic of that function.
Yeah, exactly. That means that unit tests are not the best tool for testing, change detection, for example.
So,
Yeah. So that's the other sort of testing, the end-to-end tests, for example.
We also have a question from the online audience. Sebastian is asking, what is your target coverage?
Yeah, so one of the points is that I think especially with front end, with back end, it's kind of different. So back end, maybe it does make sense for coverage, but with front end, the coverage is not a really good metric because you've got all this UI stuff, all the HTML, CSS, like how do you test CSS? I mean, that's not what the coverage is calculated from, but still, there's a lot of stuff, and you're using the interacting with the DOM, a lot of stuff in front end that where unit tests are not the best thing, and actually makes sense to be selective about the business logic, the state management, the programming part of it.
Okay, thank you. Michael.
You have experience with visual regression tests. You said like CSS cannot be tested with a unit test. Did you ever set up some visual regression testing?
I haven't, but I know that Storybook has some integrations like Cypress and Jest.
screenshots.
Yeah, screenshots,
Yeah,
also
like
snapshots
from
of
before and after, and then you really visualize the difference in pixel.
And there is even
Yeah.
some implementation for diffing this in CI.
Yeah, is it called Persio or something like this?
yeah, I have screenshots or just snapshots of the HTML if the markup changed, then also you can catch it.
And I saw similar thing for the
But I mean,
playground.
sorry to interrupt, but snapshotting the HTML, if you like change the styling of a class name, you will never see it in a snapshot, right? So in your snapshot, you should really put everything in that is connected to this little piece of code. And I guess at some point snapshots don't pay
Well,
off
with
that
CSS,
much.
you need to see it basically. So
Exactly, with CSS you need to see it to really test it, and then you also have to test like all the different browsers, right?
Yeah.
Pretty cool.
Okay, thank you. No more questions in the chat. No more questions here. Okay, and guys told me that you are not going to. I'm not sure, Maciej, if you didn't. No, you didn't. It's okay. So, Vojto Okay, so during the break, we are going to try to fix the sound. Kachi, is it still gone? Or after 20 seconds, when it gets to you, it's back?
How is offset
Or
working
ignore
here?
Mm-hmm. Yeah.
Offset?
Is the sound gone? Can anybody try it, please?
Yes, it's back.
Because it's awesome. So yeah, so the thing we were doing wrong was that I got myself out of the stream, and therefore I got myself also out with the sound. So sorry for that, guys. It's a little punk today, and we are gonna be back at 2020.
Also, can you hear me?
Yeah, now it should be okay.
I will wait for feedback if everybody can hear me, and then I share my screen. Then I'll share my screen.
Can you hear us?
Yes, Kirill says yes.
So, in that case, it's my pleasure to welcome our last but not least speaker, Vojto MAŠek. He is our head of engineering. Awesome, perfect. And he's going to speak about techniques for lazy loading your JS bundles in Angular. So, Vojto, yours.
Thank you very much. I can see the presentation. That means that you can probably see it too. Hello, I'm Wojciech. Today I'll talk about lazy loading, and it won't be just lazy loading in general. For example, in Angular, there is the router level lazy loading. It will be much more deep dive into what you can do with JavaScript or TypeScript code, especially in Angular. So I'm head of engineering in FlowUp. That's a small software development company. We try to deliver very quality code. As you've seen from Maciej, he's quite passionate about it, and my little passion, at least for last few months, is actually lazy loading. So I did this talk to summarize everything I've learned or what I tried and actually worked. So you can probably it can be useful for you when shipping production ready applications. First, let's talk about tooling. So what tooling I normally use or I like to see when having a lazy loading, when implementing lazy loading or when investigating the bundle size. For example, this one. It's a very simple, lightweight import cost plugin for WebStorm or VS Code that will just show you the overview of how much you are importing. It's not 100% right every time, but it gives you some glimpse of what can you expect from that import. You can see that fastDB equal is, not more than 1 kilobyte, but not much, so very lightweight. Then there is Hammer.js, which is, not big, but also not very small. Then there is RxJS, actually old one, because it's more than 50. And then there is things like ngXquill, which is the implementation of vCivic editor, which is quite huge. You can see that it's almost 1 megabyte. So another tool, or in this example website, is Bundlephobia. I'm sure that a lot of you already heard of it. It will show you more information than this import cost, but you can easily search for any npm package in there, see if the library is tree shakeable. You can see if there are any side effects, what are its dependencies, and you can see the bundle size, minified and gzipped, and so also some estimation of download times, because that's quite important, especially on mobile devices. Just as a small comparison, this image screenshot of that website is actually a little bit bigger than the whole RxJS 7 itself. I also think that also RxJS 6. So this image is 43 kilobytes. When you do bundle size analysis, there are also quite nice toolings that you can use. And in Angular, we are building applications with Angular CLI, which under the hood uses Webpack. And with Webpack, there is the Webpack analyzer. So you can build your application with stats.json or flag that will enable the stats file that is in form of JSON that you can consume via the Webpack bundle analyzer. So you can just run it like this with npx, or you can add it to your package JSON script and run it as that. And it will actually show you a very nice overview of how your application look like in form of chunks, or the bundle size separated into multiple modules. We'll be talking about these modules more in detail later on, but now you can have a look on this very nice colorful image. And one thing about it is that it's not only an image. As I already mentioned, I've spent some time, few months, digging a lot into bundle size analysis and investigating where can we do some improvements on certain applications. And every time I have this chart open, my girlfriend likes it very much because it's all colorful and there is a lot of it. And I want to show you that it's actually interactive. So I have something prepared here. It looks like this. This is the some application. I think it's our company website, and you can see that it's all interactive. You can actually like show this drawer, then you can disable something, or you can disable all and only show some of the bundles. It will be very interactive. It will show you what's inside of it. You can have a look. There are some services, there are some helpers. This is map component. This is actually an SVG map component loaded lazily. So you can investigate a lot using this. You can also switch between gzipped sizes, stats, which means everything. Parsed means only what you have in application, and gzip is what you have in application but gzipped. You can use some regexes, so it will filter stuff. Very, very useful technique and very useful tooling. Okay, let's continue there. So already showed this. When I already have this overview and I see some things, I know that there are things imported that I maybe don't want it in my application, or it seems too huge, or things are just looking like they can be improved. What can I do with that? So first thing you all probably know, because we all read the Angular docs, is that there is router level lazy loading embedded in Angular. It's very simple. You can load application only like you can split it in parts and load only when things are needed, and it's integrated in router. So you can use load children instead of referencing children in routing. And there used to be this old syntax that you can see at the bottom, where load children is an import, and it actually uses this hashtag services module to reference an actual module inside this file. And the new syntax, I actually don't remember from which version it is, but it's not that recent. It's probably 7, maybe something like that. So it's around for quite some time. It actually uses a dynamic import. So you dynamically import homepage module and then use this module export to extract homepage module for the load children, and router will use this declaration for this path to load what it needs at that certain path. It's very easy, very useful, and it's basically the least thing you could do in your Angular. This should be a default when creating the applications, router level or lazy loading. What can we do more than that? Because not every time, not everything ends here. Not every time application can be actually split only on route level. And sometimes you'll also work with legacy code that was not intended to be I'd say that route was never only or the biggest source of truth. So sometimes you have these problems. There are options what you can do. One option is dynamic import. I already mentioned that there was some dynamic import used. So what is it, the dynamic import? Well, in latest AS ECMAScript specification, function like import was introduced. This function like import returns a promise, a native promise, and it can actually be used to dynamically load a code, because if you specify what should be imported and then in a then statement do what you need to do, everything behaves lazily. It will be invoked after the promise resolves. It is very useful for this asynchronous way of importing things dynamically. You can avoid, with technique like this, you can avoid loading, parsing, and compile cost of code until it's actually needed. And why I'm mentioning that there are some parse compile costs? Because load, that's very simple. Load is what you actually pay for, and by pay for I mean in quotes when it's transferred to network. It's the actual network data that were transferred. That's load. But what's parse and compile? Well, that's the main difference between images and code. Because if you have a lot of assets, for example, images in your application, they are usually bigger, and you don't mind that some images are in hundreds of kilobytes, because they are only loaded. They are cached, only loaded. That's it. When they are rendered, they will not impose any other cost to your application. But with code, that's different, because it has to be parsed, it has to be compiled, it has to be actually used by the browser. So there is additional work that browser does. A lot of it Michael already mentioned, that sometimes browser can idle, and you actually aim for it to idle, ideally every time it should have some idle, because otherwise you are having performance problems. To enable the dynamic imports in your application, you have to switch on a compiler option. You have to do it in, or you can do it in tsconfig app.json. I just got a message. Okay. You can do it in tsconfig app.json, and you can specify either ESNext or ES2020. Why these two? Because yeah, that's it. That's when it was introduced, and again, as I mentioned briefly, it doesn't affect the browser compatibility, because all module resolutions are actually resolved by Webpack behind Angular CLI. So it doesn't really matter from perspective of import what is specified there, but it won't work properly if it's not specified. At least, like in my experience, it didn't. So be careful there. But you will notice when you see that things are not lazy loaded properly, you will know that this is it. What are, and when you imagine some out of the box thinking, what can you do in Angular beyond router level lazy loading? For example, you can lazy load things in pipe, because as we all know, pipes are things that they are basically like pure pipes are pure functions. And if function, there is an input to it and there is an output to it, it can also, the output can be asynchronous. It can be stream, it can be promise, it can be observable. Later on you can asynchronously subscribe to it. You can lazy load in the pipe. So if there is some third party library which you are using in pipe, or there is an option to use it in pipe, lazy load it. Why not? Pipes are great at running code on demand. They've been written like that. They will, if you use the example like this, it will only execute the code or third-party library when it's actually needed. And what I mean by actually needed, I mean that it's actually invoked from the template, that pipe has to be actually like run. It's not enough that it's just present in your application. It has to be used in the template, so it is executed, which is amazing. That's what we want. So there is a markdown example, simple pipe, which what it does, it's transform string. You can see it here. Input strings, string, output observable string. Why? Because it will try to import the marked. Marked is library for transforming to markdown, and the markdown declarations and markdown strings to HTML text, and we will basically map the output, the markdown which was inputted as a string with this parse, which we extracted from the module export, and that's it. The observable of markdown will be returned. How do we use something like this? Well, again, very simple. We'll take the description of this card or markdown container, use our pipe it with async, because we need an asynchronous subscription, and then we also, like, a good practice is to sanitize an HTML. We will use again custom pipe that will sanitize for HTML, so we don't have any problems there. Another cases of lazy loading, yes, there is things like, for example, highlight.js. Highlight.js is again library which is very heavy. It supports a lot of languages, a lot of highlighters, and as you see in this example, which is a screenshot from the Webpack bundle analyzer, the parse size of it, so what is actually in your application, is almost a megabyte with every of these highlighters included. So you can actually highlight the mathematical language with it if you want, or there is somewhere SQL probably also too. You cannot even read the languages we actually, like most of us use. The CSS or SCSS is somewhere here, so you can imagine how big these highlighters are. What do we want to do with this? Because yes, we can definitely lazy load it with same example that I shown you with Markdown, but we want to do something beyond. We want to load this only when there is some code to highlight, and we also don't want unnecessary JS to be loaded or passed. So if these things are not needed, they should not be loaded. And what we can do is that we can actually write it that way and have a 95% reduction in size, going from 900 something to 40 something. You can see that we are only importing the core, which is pretty small, the SCSS, TypeScript, Markdown, because we only need these languages. For example, like in our blog post engine, we know that like nobody will be using something where you need to highlight the, I don't know, maxima. I don't even know what maxima is, and so we can just strip it out. How did we strip it out? So first, simple pipe. This is basically same as the example before, but we are also inputting some like the language that we are actually highlighting for. Otherwise, it's quite the same. And this is the implementation of a pipe. Again, nothing crazy there, but there is one difference. You don't have to focus on this. This is highlight.js specific code, but you can focus on this, the line 5. You can see that we are not importing highlight.js library as a whole from Node modules. We're actually importing highlight languages, which seems like it's in our file system. So this is our TypeScript file definition, which we actually wrote ourselves, and I will show you. This is it. There are multiple imports of things that we actually need, of the highlighters. They are called highlighters, and we are defining them like yes, again. So highlighters, we are defining them like this, and there is just one interesting thing to notice, because like it's a small micro optimization. For example, you can see that CSS is declared as SCSS. Why? Because CSS is subset of SCSS, so we can use the same highlighter for it. The output will be same. We don't need another highlighter for SCSS. It's just a small micro optimization. Same for TypeScript, because it's a subset. The JavaScript is subset. This is just because we sometimes also offer the abbreviation, so just like this. And we basically saved a few more kilobytes doing this, but again, micro optimization. Then we register all of the highlighters like this. This is again highlight.js specific code, export it like this constant, and you can see that this constant is then used here. So only the highlighters with language provided and with highlight auto without language will do the trick, and it all works in a pipe. Very simple. Load it only when needed, highlight it on demand. Everything that we've seen so far was using the dynamic import. I've already mentioned the dynamic import was added with like ECMAScript 2020, but then I also said that Webpack is actually wrapping or doing something to the dynamic import. That's true. What we are using in Angular is basically a Webpack dynamic import, and this Webpack dynamic import is a little bit more dynamic than you would just thought originally. For example, you can do something like import foo, but that will not be supported because foo could potentially be any path to any file in your file system or anywhere else. So this is not cool. It won't work. What will work is that you can specify at least something, and if you specify at least something, Webpack will kick in, and bundling will be limited to a specific directory or set of files, and this could be really specified to a pretty good granularity, and we have an example for this. So every module that could potentially be requested will be included in a Webpack. So it will actually create chunks for everything that is found in this path that you specified, and that thing will potentially be lazy loaded if the conditions are met. So there is this example. You can imagine that this function is actually something that will detect the language of the visitor. So like if the visitor is have a preferred language for English set in browser, language will be English. And if we import dynamically with this template string syntax, it will do folder locale where all the locales are, and substitute the language there, only import or only bundle the JSONs, and you can then do something to this and actually for example register this language, or do something with it dynamically only when needed. And yeah, it can be very useful for cases like this where you are importing different sets of data, or you are importing different localizations or imagination. There are some magic comments to this Webpack import, and again, already used it multiple times. Maybe you've noticed it during the presentation, but here they are all together explained what they do. So this is the dynamic import, very similar to the one shown before, but you can see that we say that Webpack include regex only ends with JSON, and Webpack exclude everything that is prefixed with not prefixed, which includes skip import notation, and with JSON will be actually excluded from bundling. And we are also saying that it should all be prefetched. We'll explain what prefetch means. There is also single target, again just specifying some import. But there is the interesting part that we are explaining that exports, we only want what is the default export of this, and something that is declared as foo. This can be function, constant, anything. So we can actually pick things. This is like when you use the curly braces in normal import when picking out picking out what should be actually part of the that import. And we can also name things, whatever we like. If we don't like the original name, we can write anything there. And just a brief explanation. You can name chunks, preload, prefetch, select different modes. One mode is lazy, which is default. So every dynamic import is by default lazy. And you can override it by something different. For example, lazy ones, which is a really bad name. As Maciej said, it's very crucial to choose a good names. Lazy ones doesn't mean that it will only be loaded once. It actually means something completely different. It means that files will be bundled together in one bulk. So if we use lazy ones for this, this is actually probably the only option we can use it for. And by that, I mean like for multiple possible targets. If we use the lazy ones, it will actually do that all of the locales will be bundled into one big locale. So sometimes that can be useful. You can also specify that it's eager. Eager means that it will basically be loaded with the no extra chunk is created, and it will be loaded with the current chunk. So basically not lazy at all. And weak, that means that it is only resolved if chunk was already loaded. It never performs a request. Again, sometimes it can be useful. I don't have a good example there, but it basically means that if I didn't use this yet, I don't want to, just skip it. Okay, that was magic comments. Yeah, and you can also include exclude files that was explained, and you can select specific exports. Multiple times there was already this keyword prefetched shown in a code. What does it mean, prefetch? It's a hint to the browser that resource might be needed, and you can imagine this hint as a link in a HTML. It's literally a link in an HTML head, I believe, which will be specified as prefetch, and this will tell browser that hey, I might need this, but you, browser, shall decide whether loading this is a good idea or not. It leaves it to a browser, and browser usually does a very good job with this. So it loads things properly, and then the overall feel is faster, because if you have things prefetched and then for example, markdown will actually appear with that pipe in your HTML, it will be basically rendered instantly, like it was not asynchronously lazy loaded. It will seem like it's not, but it actually is, because that code was never parsed or interpreted. It was just put into a cache, which is the main difference. It is useful when a resource is likely to be used for future navigation, or if it's one click away. That's a very good definition. If something is one click away, that means that user can probably be there very quickly, and it's a good idea to prefetch it. Versus preload. So there are things that you want to preload. It is basically a declarative fetch. What does it mean, declarative fetch? It enables you to force browser to make a request without blocking the onload event. Onload event is the document or window event that will signalize, when something is loading, or it's a DOM thing. So you usually don't want to mess with this. You want to leave browser do things with loading chunks and code, but sometimes you just want to be very you want to force the browser to preload it. It is useful when you have high confidence that things will be used in current page. Like you need it now. chunk or feature module I'm loading is loaded now, but it is probably smaller than the third-party library it will be using dynamically. So preload that third-party library, because otherwise we will wait for it, which is not good. So you will use preload because you are certain that it's needed. Yeah, what is it useful for? It's key scripts, so code. It's useful for fonts. Most of the websites on the internet actually use it for font, so that's very common. It's also useful for above default images if they are put in dynamically or something, or if it's a static HTML. Sometimes people do it like that. It makes sense. It's easily controlled because you can specify the resource type. So its granularity is very much controllable by the resource type. There is a code splitting in Webpack, and why I'm talking now about code splitting, because it's a very close topic for the actual lazy loading. The lazy loading is something that basically goes hand in hand with how big your bundles are, how big your application will be. And if your application is not split properly into chunks, shared modules, and everything, then you might run into troubles, and you often do. So let's explain the code splitting. There is a vendor chunk, and not every time you see this, but when you see something that only holds Node module things, and usually it's Node module and third-party scripts, then it's vendor chunk, and they are pretty common in applications. So you know that this is something that is basically loaded there synchronously with main chunk, so it's just an extension, like a longer hand of the main chunk itself, but it marks things and as vendor. Why it does that? Because thanks it's coming from node modules or third-party code, it is usually versioned, and there is a high chance that if this actually has the content hash, that it won't change that often, so it can stay cached. It's useful for this because main chunk can be changing quite often. There is async chunks, which is basically every chunk in Angular that will specify as a feature, like lazy loaded feature or dynamic import, things like that. It's basically an asynchronously loaded code which will be lazy loaded, and it depends whether it's lazy loaded instantly, so not so much lazy loaded, for example, like on initial load, or whether it's something like one click away or one navigation away. As an example, every route feature module is this. Then there are common chunks. Common chunks are something that people don't usually like them because they can get messy, they can get big. If the application structure is not good, they can end up being really bulky, and they basically hold all the common code shared between different chunks. Reason there is so the same code isn't loaded twice. Basically, if two or more async chunks need same code, it won't both be loaded in that async chunk. It will actually be split into common chunk and loaded separately for just once. Webpack will take care of that. How big these shared chunks can be? How big of a mess can they be? Well, they can be sometimes pretty big. This is actual screenshot from one shared chunk. It's meant to be horrifying because it is. It was. You can see that there is a link for the import graph visualizer, which is a tool that Maciej created, and it actually took serious minutes to render this, just to render and parse this. It shows you the application structure based on the actual imports. Every node of this chart is an actual import from file to another file, and we'll see it now. This is before refactor and this is after refactor. You can see that was a high charts library. So this is a library that renders charts, and by charts I mean like graphs, basically like charts. I don't know how to explain it better. So it can go from this to this. What did we had to do this transformation? It seems complicated. Like this seems like weeks or months of refactoring. No, it was actually pretty. When you know what you are doing, and you have the tooling, and verify that where is the problem. We identified that the problem was in a utility file. So people usually create utility files that just hold helpers, a lot of constants, a lot of functions, and this utility file can get big over time. Everybody puts functions and code there. It's imported from everywhere, and that's what you see, the circle dependencies and a lot of imports. I cannot even see that utility file. There's probably multiple of them. And what had to be done is just extract these functions and these constants to a separate file. Literally take them, put them into a separate file, that's it. Suddenly code splitting will stop working properly, because Webpack can actually handle that again. It can actually look at the imports properly. It doesn't look for the Webpack that, well, this is a file that's needed everywhere, let's put it in one shared horrible big chunk. It will do it properly. So it can be very helpful to understand what's going on there. Always split your helper functions into multiple files. You don't have to take it that far. Like if they are used together or they share some common principles or responsibilities, then they can probably live together. But avoid something like utils ts. That's not a good idea. We can load components dynamically. There is the ultimate screenshot of just some, I've googled this, just some random dashboard with charts, with I don't know, that there can be calendar, there can be multiple things. Well, a lot of components on one page, usually different ones. So there can be different library drawing this, different library drawing this. I don't know, some real-time connection to Firebase doing discount, and this will be another widget from, I don't know, some sales department. So a lot of components in one place, and not every time every one of them is needed. This is a perfect case of the dynamic widget boards or views, where you just have a ng4 and ng switch, or a lot of conditions displaying different components based on the configuration or data. This is a perfect example for lazy loading components dynamically, because you can actually wrap components with ngIf and ng switch, and do some condition whether it should be displayed or not. And when it's not displayed, it will actually not be loaded, because it's dynamic. So we can use library like ngxt. It's down there, the package. Have a look. There's a lot of them. I just happen to like this one, and I've used it multiple times. You can achieve a lazy wrapper of the component that will act as a proxy for the lazy loading the actual component. And what I mean by the proxy is that it will actually propagate all the inputs and outputs, and it will handle the dynamic loading of itself. If it's a simple component like a chart that only it inputs data and outputs some, I don't know, click or full screen event, for example, like this, inputs data, input for disable zoom, output for full screen trigger, that's it. You can do something like this: dynamically load the component, use this is the library, and this is the dynamic load. Very simple code. You can have a look on the details in the documentation of the tooling, or you can use any other. There is literally loads of them. I just happen to like this one, and like lazy wrappers for components can be achieved this easily. We are almost at the end, and I will just quickly tell you what I didn't cover, but just because it was already getting too long and I didn't want to scare you. But there can be dynamic component loader services, which will actually handle the component module. It will respect the component module, its providers, context, everything. So if there is more complicated component that actually has its own store, that depends on some other things, has some providers, calls for an API, blah, 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 there can be dynamic component loaders, maybe in next talk. Lazy loading can be also, you can also use some defer strategies, and by that I mean you can wrap usages of components using heavy libraries with asynchronous conditions. Just something like ngIf don't display this until this promise has resolved, or this observable has nexted. It is very useful when working with messy or synchronous code. If you already have a horribly huge components and code you cannot really refactor or touch for some reasons, and you need or want to do lazy loading there, you can probably wrap it like this. It can be very trivial. It can also be hard in some cases, but yeah, it could work. And you can also perform lazy loading on router resolver level. So it's a bit different than normal router level lazy loading, just because we are using the resolver. Now, resolvers are a handy way to lazy load data or code if your route plays a big part in whatever certain feature needs. And what I mean by plays a big part, for example, if there are some query parameters or some, something is specified in that route, and it isn't the path itself, but it's, dynamically there. And based on this, that you have to preload some data or load some chart library. For example, that you will be displaying a Gantt diagram, so we need a Gantt library. You can do it like this. And I also have a few tips for the end. Remember that any lazy loading strategy is most effective with combination with proper caching. So if your application isn't behind CDN, if it's not cached, if there is no content hash, then your lazy loading is not that effective. You should focus on this first. Any resource that is not essential for the page and could be lazy loaded should be lazy loaded. You should make efforts into it, and you do preload and prefetch code when it's likely to be used. Don't just put lazy loading there and not care about it because you have fast internet, fast machine. Sometimes the prefetch and preload can introduce tens of % of improvement in page speed or page load speed. Write tree-shakeable code. It enables more efficient code splitting, embraces good architectural practices. If you don't have tree-shakeable code, if you have horrible long shared utils files, and if you have everything in one big state management and one big share module, then talking about this is nice. But as Maciej said, you have to start doing things. Literally sit down, do the architectural proposals, draft it, start doing things. And last is that you should always observe your bundle size before you run into troubles, because when you have the problem, when your application is huge, when it loads forever, it's sometimes, I don't want to say it's too late, but it could be. You can be beyond point of no return. Sometimes it's just easier to write it again and like doing it properly. So yeah, observe your app before you go to production, and set up some observation patterns like Lighthouse CI, or some things. GitHub Angular actually has the bundle budget, so yeah, use that. And that's it from me. Hopefully it was it explained the techniques. If there are any questions, feel free to feel free to shoot now or contact me later. I'll be happy to answer. Thank you.
Amazing.
Awesome, Vojto. Thank you. And we've got a question. I'll show it. So, if there is lazy load in pipe and the pipe is a part of a component, is the lazy load third-party function loaded every time?
Is the lazy load third-party function loaded every time? If the import is written in a dynamic import format, it's only written when that code in that pipe is executed. So you could basically tell, like, if you put a console log into that transform method of a pipe, it is only loaded then when this console log is locked. So that's a simple answer. So no, it will be only loaded when executed. Same as the code of the pipe is actually performed when executed.
Okay, thank you. We've got no more questions in the chat. Any questions in the room?
Yes, of course.
Come on.
So, how often do you apply these cutting-edge performance optimizations in practice?
Well, often. I'd say that at least from the products we've been building and projects I've been working on, in each of them there is something of it, and I could even exclude the the basic router level lazy loading, because that's a must that should be in every project. But even beyond that, like 99% of time I see something more dynamic there.
And do you believe it really pays off? Because, I mean, you need quite some knowledge to implement that stuff. You also need really a big expertise to really dig into the code, understand where you have to apply the change, understand how you do it. Is it something that you say it really pays off if you know how to do it? This is the stuff you should do, or would say that is like mid-sized priority?
I'd say that scratching the surface of this isn't that complicated. As we already seen, but maybe you agree, maybe you don't, but at least, like, seeing this talk, you should probably already have some overview of what you can do. And then when you see the, like, I'm about to use a huge library in my code, or I'm about to import something that's probably not needed for every user, but admin for sure needs a vSphere editor. Then why should a user that accesses your very minimalistic block page pay for the editor that only admins has there? Either router level lazy loading or dynamic loading of something should be in place, because otherwise, you're basically wasting a potential of that website. It loads slower, and again, it's not that hard. With latest Angular, with dynamic imports, just a little bit of understanding of async await, or the promises, and you are there. And I know that you are not a big fan of promises because they are not cancelable. But again, you can wrap them. You can use observables. You can defer that. Amazing. Again, you are at a place when you have dynamic import that is cancelable. Code will not be executed if you abandon the site before it's loaded. Another great use case.
Can I add another question? Because I'm pretty interested in this preloading, prefetching techniques where you really demand stuff when you need it and not before. And really good websites that are like measure constantly to see what changes they introduce is Google. Google's Google Drive, Google Meet, and other products. And if you enter them, they have really quite a bunch of those optimizations. And I'm curious if you ever compared your implementations with stuff that, for example, Google Meet does. I mean, to like give
Yeah.
audience some more visual context. If you enter the Google page, you see the player, like the video player, and you have the play button. And sometimes, if your internet is slow, you click the play button.
It does nothing.
Not reacting right away.
Yeah.
So if you then measure it, you will realize that the video player and the button is just like a fake dummy HTML stuff. It is like it's something that will get replaced. That the click is like recorded, replayed later on when the stuff is loaded, and you basically trigger, or could trigger, because it is also time-based, could trigger the loading with your user interactions. And I am really curious on outcome of your comparisons.
Yeah, well, that's the thing, that you can start with. You have to display a video player or everything, something that loads for quite some time. So your first step would be to dynamically load it. You can put a loader there, so there is something, and then you have the ghost element, replay the event. I don't know, even do some more crazy stuff, like when you user hovers over it, it will actually prefetch only then, because this is amazing with like inputs element. If for example I mentioned the VCVig editors, so you basically only need the editor if user intends to write something. If they are just reading the comments or content, it only has to be styled nicely. It doesn't have to be editable. So yes, I do these comparisons, but it is to get to a point where you can compete with optimizations that Google either Meet or Drive do. You are looking on an investment on a lot of effort, and not only code-wise, you have to actually understand these things. And that's again something like I shared the comparison for preload and prefetch. That's something I had to personally research maybe like 2 months ago, because I didn't understand that completely. I just needed that at some point, and I was wondering, does something like that exist? And I actually realized, yes, the preload was actually created recently by Chrome team. Prefetched it was other way around, maybe, I don't know. But one of them is new. One of them exists for quite some time. Research has to be there, and some understanding too. Otherwise, there's actually a warning if you go to that slide mentioning prefetch and preload, and open up the documentation on it. There is actually quite a big warning that you should be careful with preloading, because you can cause more harm than usefulness.
What would be the harm of what could go wrong with all the techniques?
That with preload specifically, the harm could be that you will actually preload a lot of stuff that you don't need. And as I said, preload is in comparison to prefetch is like, you know what, maybe browser, take a look on this, maybe import it, maybe not, I don't really care, just maybe it will be used. But preload means put it in that head, otherwise I will not do anything else, just put it there because I will need it immediately.
It's like, as far as I understand it, preload and prefetch differences from the priority that the browser, like if you fire 100 HTTP requests, you have like 98 default ones, and then you have one preload and one prefetch. You basically can know exactly what the order of those requests will be, right?
And the people also compare that, and this is again very advanced topic, but they compare that to HTTP push, the preload. And in documentation, it's also mentioned, and they say that they are basically complement technologies, just because sometimes, because you are on client and you do preload on client, you as a client know more about what should be preloaded than the server does. So they are complement. But that's something for another 45 minutes.
Definitely. I mean, I really like the combination that you pitched, where you have some user interaction that triggers the preload or the prefetch. So you really have like the best of both worlds. You
you have like a reliable technology stack that prioritizes
Yeah.
requests, and you have like the one thing that is really like essential for that, like the user that triggers whatever you define. And I guess this is like a really perfect combination and perfect match of both technologies.
That's probably takeaway. Always when you design the application, always think of what the user will do in that application. Otherwise, you are not creating application for a crawler or something. You are creating it for a browser, for a user.
Yeah. Really good point.
There are no other questions.
I heard that there is a karaoke after that.
Yeah, there is.
That's definitely happening.
Maciej, question?
When you have a website and it's got slow load time performance and analyzing, what are the first things you're looking for? Or the classic mistakes?
Classic mistakes. Oh, well, there's one mistake that was actually fixed with latest Angular, like some patch release, and that they switched the default behavior of NgBuild to production, which is amazing because it sounds funny, but and I'm not lying. When I had a look on a lot of applications in my life already, and there is like I could probably count it on two hands already where people have been deploying non-production builds, and just for this reason, because like they thought it's production build. So at least 4. Albert says at least 4. So yeah, even more. Okay. So that's the most classic one. Then images. There is a lot of things that images can cause problems because they are just not optimized. And if there is a way how user or users can set content, always optimize or do something with the images, because there will be a certain point in your life when you will be debugging an application or load or something, and you will notice that there is an image which has 45 megabytes just because someone put a photo from a vacation there, unoptimized in full format of the best quality. Can I still continue? What are the mistakes?
Yeah. I was like trying to hit in the same spot.
Yeah.
And wanted to ask another question on downsides.
Downsides.
This is okay.
Yeah.
So you mentioned if you load something a little bit later, not right now, it's good because the stuff that you really need is clear faster, and then you have time to load stuff later on. So I imagine a scenario where I have this, it's hard to find words, professional pages with a lot of advertisement on it.
Yeah.
And maybe also the real professional pages that like big brands like I don't know, some
like news?
Some fabric brands like fashion.
Okay.
I was searching this word and I had fashion brands or whatever, like they do a lot of like visual
selling clothes,
sell over their visual appearance.
Has to be nice.
Also sell because they people can see their images faster and so on, and sometimes they are forced to add some edge side includes which displays not advertisement but maybe similar stuff for tracking or similar stuff that they will display later on. And I was wondering, is there a downside if something later on pops in the screen and just takes some space?
And I think that there's a term for it that we are probably searching for. It's a content jump, something like that.
Cumulative layout shift.
Layout shift, yes. And there is a big downside of it. So if what you are doing can actually cause that, images are a great example, or iframes, things that you don't know the dimensions of, can be causing this. Then you should think of it as some, put it in containers, something like give it the dimensions, because otherwise you will end up in a messy situation. And there is always a good idea to include like some progressive loading of these things, or put it away from content. That's like a very bad habit of these. And I wouldn't even say that the clothing sites are the problem, because you can have cards, and they can just place it in one of the cards, so you can probably know the dimension of that card. That's fine. But when it's in the article, that's a problem, because, or when it's somewhere where you can actually interact with, and then you try to click, and you click on the advertisement. That's horrible. That happens to everyone. Well, for you it is horrible. For page owner, well, most of us are programming these pages, so we maybe some of you actually do that on purpose. I don't like it.
Yeah.
And I know a lot of scenarios where advertisements on pages can be placed properly and like do not be harmful to user. And there are good initiatives on this to that are fighting the ad blocking culture. I'm part of the ad blocking culture. I actually don't like ads that much, so I don't know. I don't have a strong opinion on this.
What would be the follow-up question? What would be technically, like really hands-on, like what should I do? You explained to me the problem, you told me how bad it is. I'm scared, like I have so many websites on that don't include those optimizations, and I really want to start tonight to fix all of them, right? But what is like the first, second, third step that I should do to go to all my applications and see if I can introduce those optimizations or not?
First, that's why I ask if I should continue there, because when you verify that you build for production everywhere, then check whether you actually need to support the older browsers. Because if not, you can get rid of a lot of code. You can just optimize a lot of things. Built for modern browsers, always.
Like especially dedicated to the problem of cumulative layout changes.
Of this, what can you do? Because like you want to introduce lazy loading somewhere, but you are afraid of cumulative layout changes.
After this talk, like I have to introduce lazy loading, no other way around, right? So.
Well, be sure that everything that can cause it has dimensions, that is wrapped.
So I'm not sure.
Yeah.
Because I'm searching this term in my head. I was trying to tease you in that direction and answer it, but did not work out. I know that there is some CSS.
Yeah, there is.
Property, how is it called? Area boundary or something like this.
Yeah.
Where you can like say, okay, this stuff here in the future will be that big, so make it that big now.
Yes, I don't know the certain name of it, but
you know it exists. Right?
Yeah, it exists.
I'm not insane.
It exists. You can, but again, that's not something that's fully supported. So still,
it's pretty new edit.
Yeah,
and was money pitched it a couple of weeks ago, I believe.
Yeah, and that will be a reality in 1 or 2 years. Okay. So again, maybe we'll have a talk on it soon, but currently I don't think that that's a viable option for people that ship code that has to run on Safari.
Do you believe that in the future all the different browsers will support optimizations in terms of layout and content visibility things? I hope so.
I hope so very much. I actually recently I tried creating a very nice component for images, the picture wrapper that has multiple SRC sets and loads the images based on the dimensions of the site and whether WebP is supported or not. Just a really nice wrapper for this. And I was pleasantly surprised that it's already supported everywhere, but very certain cases which are like 1% or something. And there are fallbacks, so you can you can easily use it. And this is something that wasn't possible a year or two ago.
Yeah, so they did a lot in recent years. I remember.
And even the lazy images with the thresholds, with scrolling and everything, it now works. It has very good support. Even the vertical scrolling now works properly, not only horizontal. Well, I said it vertical. What is vertical? This horizontal works. Horizontal works. Yeah, vertical always worked. Horizontal now works too. So carousels are now fine.
Carousels, I guess, like the main pain in the
Yeah, yeah.
Not only like rendering stuff, but also memory leaks and
That's-
so on, like the ticks.
That has to be everywhere. Like every page has to have a carousel. Otherwise, it's not a web page.
Okay, have to remember. I'm bound to know.
Okay.
Thanks for your answers, by the way.
It was my pleasure to be specific.
You know you can always take the time to thoughts and answers.
Okay, so I guess that's it. Wojto, stay there because you've got the microphone. And I will just say that thank you all for watching. There is going to be the recording on our YouTube, so you can follow us on YouTube. You can also follow us or join our meetup group, which is called FlowUp Meetups, or follow also our social media if you want to know about more about future events. And what do I want to say? Yeah, also, if there is anybody who would like to perform a talk, we've got a call for proposals on our meetup group. So if you hit read more or something in the description of the group, there is a link to our CFP, so you can fill it in. And you can speak up. Everyone's welcome, as this is a community meetup. We welcome everybody. And do I want to say anything else? No, I don't. That means that I'd like to thank to Vojto Mašek, Michael Hladky, and MATÍJ CHALK for amazing and I guess also quite exhausting talks. We are now on three hours exactly.
3 hours.
But I told them it's gonna be exhausting. So they should be prepared for it. And yeah, Kirill says that great talks, great speakers. Thank you, Kirill. Yeah, I told you it's gonna be.
Kirill is the best. Shout out for Kirill.
Kirill is speaking next time.
Applause for Kirill.
Yeah, you definitely should have the talk next time. And yeah, that's all from us. Oh, come on. That's all from us. So have a nice evening and see you next time. Thanks for watching. Bye.
Bye. Bye. Bye.
Okay.